hello everyone. It's my pleasure to be at least a digital there present at this meeting. And it's about drones, and that's why my talk will also be about drones. And the topic is ultra-wideband meets drones. So ultra-wideband is wireless technology that we work at IHP. A short question, can you hear me?
Yes, we can hear you.
Okay,
I have to talk because I have a microphone.
Okay, good. That's one thing that I learned in this COVID time, that is always good at the beginning to ask about the feedback, because it happens to me several times that I was speaking quite a long time and then I realized I was muted. So it's better to ask at the beginning instead of repeating all things again. So I was telling you that it will be about ultra-wideband and drones, wireless technology, because with ultra-wideband we can do not only wireless communication but also precise localizations, and it is quite important and attractive for various drones applications. An example that I will be talking today is landing and coordination of swarms. And it's the overview of my talk today. First, I'll just say a few words about IHP, because I work at IHP, and just for those who don't know where it is and what is IHP, I'm going to introduce it briefly. Then I go to ultra-wideband, just to also briefly explain what this is all about. It will not be an academic lecture about ultra-wideband, but just very basic so that you understand and know why it is so attractive. Later on, I show two projects that we are currently working on, periscope and upwards. And in these both projects, we use this ultra-wideband for different drone applications. And finally, I will conclude my talk. So let me first start with IHP. IHP, it's not new. So it dates back to 1983, which was still the DDR time here in Germany. And at that time, IHP was dealing mainly with semiconductor. And even the name, at least the acronym IHP, it stands for Institut für Halbleiterphysik. So in this, in English would be something like Semiconductor Research Institute. And now we still do plenty of tasks with the semiconductor, but not only semiconductor. Yeah. So that's why now we are not only Semiconductor Research Institute, but we do more towards electronics. That's why now the name is Innovation for High Performance Microelectronics. Yeah, but still the semiconductors in the center. Even in this photo of our research institute, you can see that this part, it is our own clean room, so we can fabricate ASICs here at IHP. So and there are not too many such institutes in Europe and worldwide. They can also do their own ASICs, and that's what we do. So the location is, when you look here at this map, is we are exactly at the border with Poland. So in Frankfurt under Oder, so let's call it small Frankfurt, and you are currently in Wildau, which is somewhere here close to Berlin. So when you just go 80 kilometers to the east on the motorway, then from the motorway close to the border, you can see the IHP. So we are there. So what we do, apart from this semiconductor stuff, which is a clean room with our own pilot line, with BiCMOS technologies, but mostly we do with silicon germanium. By the way, a few years ago, we managed to fabricate the fastest transistor worldwide, even faster than IBM. So we are quite famous in the semiconductor area. So one thing is the semiconductor, and for this semiconductor, we need also material research. We need to just do new research on this technology. So we work on, let's say, on the atom level, so very low with various materials. And based on this, we use our, let's say, ASIC, our technology, also for let's say, top level task, let's call it. So we have also electronics departments with RF circuits and for wireless communication. So we just do our own radios, to put in these words, like transceivers, antennas, many things for wireless communication. And then when you go still up, we go to the digital world. And the digital world, we start with digital baseband processing, also for wireless communication, various protocols for wireless communication, security, reliability, like radiation hard systems. So we want to say include our hardware in rockets that are going into space here. So quite a broad spectrum of what we do at IHP. And for drones, we mainly focus, let's say, on these two departments that are analog circuits for transmissions, and also, let's say, the digital part of wireless communication. And that's what I'll be talking today about, because ultra-wideband is also wireless communication. So after this brief introduction to IHP, let me just shortly explain the major features of this ultra-wideband communication. So I think you already know what the wireless is nowadays. I don't need to explain this. Yeah, we use wireless everywhere, and the most wireless communication that we are using are so-called narrowband. So when we look at this picture, some signal is just coming in my headset. I hope you can still hear me, because there's something weird going in my headset. Ultra-wideband is that here in this picture we can see the typical wireless communications like 2G, which is now like GSM, or 3G, 4G, or 5G. They're pretty narrow. So what it means, when you look at this frequency, the frequency is pretty narrow, maybe. So here is 2G and here's 3G. Ultra-wideband is something different. Like the name suggests, ultra-wideband is pretty wide. So we can see this very wide frequency band. And it also has implications on the communications. First of all, with ultra-wideband communication, because we have so wide frequency band, the other communication, they do not really disturb us. So we can communicate even if there are 2G or 3G communications. Of course, nowadays it's not allowed to use this license of 2G or 3G or 4G, but in the future, we can have both communications at the same time. And the other way around is as ultra-wideband, because the frequency is so wide, we send data with a, let's say, low power at specific frequency, so we do not disturb the others. So we could easily just use this frequency bands of the others without disturbing them. Now it's not really allowed, but in the future it will be very, very important, because nowadays we have huge problems with this frequency allocation. So the one thing about ultra-wideband, this frequency band is pretty wide. The other thing is the typical communications like this 4G or 5G is based on this continuous wave transmission, which is modulation of the sine wave shown here. And with ultra-wideband it's different. We have just short pulses, like 1 nanosecond pulse, and because of this, it is more reliable for various problems like multipath propagation with fading. But I do not really want to go deeply today unless there are some questions. And the most important for drones is what we get with ultra-wideband. First, we have wireless communication, which is important, even 1 gigabit per second, let's say in some lab environment. But apart from this wireless communication, we also have localization. So we have both. We can transmit data and we can localize. We can find the others. Other things as we can just measure some materials, but these both are the most important. So now let me explain how we can do this localization with ultra-wideband. So I think from the physics, you still can remember that to estimate the distance between two objects, what do you need? You need the time to travel between them, and also the speed or the velocity. Yeah? So simple as that. And exactly the idea is being used in ultra-wideband to find the distance, to do localization. So as a transmitter, we are sending the frame, so it is transmitted to the receiver. The receiver gets this and sends it immediately back. And we know what is the speed of this, let's say, transmission, the speed of light. And by sending these frames, we get what is the time needed to travel from here, there, and back. And quite important here is that we need this time or timestamp very precise, even even in the clock cycle precision, yeah? Because only with this we can do this localization very, very precise. But since we work on this ultra wideband from very low level, from analog to the digital, we're able anything we want. That's why we are able to do this localization pretty exact. So here is the picture of our test that we carried out, I can't remember, 2 or 3 years ago. So here is IHB indoors. We have the long corridor, which is 120 meters long, and we installed ultra-wideband transceivers at both ends of the corridor. One is here, and the other is 120 meters on the other side. And we were measuring what is the precision of our ultra-wideband transceivers. And what we found out is by this distance, the precision is about 1 centimeter, so very, very precise. Yeah. And that's we came to the idea maybe we can use it for drones. Yeah? Why not? Yeah? That's why we are now working with ultra wideband and drones. Of course, with ultra wideband, to get this localization, we need more than just for radars. For radars, you have just sender. You have let's say the radar. You just send the waves. They are bounced back and they come back. With ultra wideband, you need both sides. You need the sender and you need the receiver. And then there's various ways you can do it. For instance, in kind of indoor application or specific drone application, the specific area, what you can do, you can install some beacon nodes or anchor nodes at specific points, like at the corners, and then each drone also would have this ultra-wideband transceiver, like installed here, and based on communication with all these beacon nodes, it can estimate its distance even in 3D coordinates. Yeah? Because for coordinates, you need to communicate at least with 3 other nodes or 3 other beacons, yeah? Because otherwise you would only get a distance, yeah? So we needed 3 of them. So here in this example, we have another demonstrator at IHP. Here you can see the triangle. On this triangle, there are 3 ultra-wideband transceivers installed. One is here, here is the second, here is the third one. And when we were moving the 4th one, like a drone, it was just moving somewhere here in the middle, then we were getting the distance to the other ultra-wideband that's located here, and then we got XYZ coordinates on this, let's say, movable, not a drone, but ultra-wideband transceiver. And that's the way how it works during this triangulation. Now you can think of how can you use it for drones. Yeah? That doesn't make sense. So we were thinking about just a few applications, but there are many more that ultra-wideband is so attractive. One is using for the landing, and one project that we are working on is also about landing, is to find where the landing platform is. Because with GPS, we get just more or less a few meters left, few meters to the right, but this ultra-wideband will be very precise, up to maybe 1 centimeter precision. The other thing is you can also use this ultra-wideband for wireless communication and for localization of drones. Like when there are several drones here, they are carrying packets, but they can use ultra-wideband to find where the others are. And of course, the other application would be indoor flying, because GPS is not working there. So it will be you can install some indoor ultra-wideband transceiver indoors and then use it for localization. So now what we now still have before us are the 2 projects that we are working on. One is Perseus, and I already mentioned it is about autonomous landing, because we think the future of drones is autonomous. Now the limiting factor, the human, so each drone needs a pilot. So the thing is, how can we do this more autonomous? So the drones are flying on missions, they're coming back and then continue on missions. So one thing is that they must also be able to come back autonomously, charge, replace battery, and then continue working. And for this, they need precision landing. They need to find the landing platform and they need to autonomously land. Of course, with GPS, you can find where the landing platform is, but for this precise landing, GPS is not accurate enough. That's why we need something more accurate. Of course, you can do it with lasers, with infrared, but we decided to use ultra-wideband for several reasons, because it works even when there's no optical, when the drones do not see where the landing platform is with for instance, with some lasers. And here it works everywhere and always. So the major idea is that here's on this diagram, on the landing platform, you need only to install 3 or 4 ultra-wideband transceivers, and then it will be enough for the drone to find when this landing platform is. Of course, the transmission range of ultra-wideband is limited, let's say to about 100 meters. That's why when the drone is far, far away, first it uses GPS to come back to the landing platform. And when it is close to the landing platform, let's say 10, 20 or 50 meters, it detects there's ultra-wideband transmission and can switch to the ultra-wideband localization. So that's how it works. First, when it's far away, uses GPS just to find the landing platform, and when the drone is close to the landing platform, it switches to ultra-wideband communication localization, and then by this, you can do this precise landing with this triangulation. What you can see here is we are integrating our transceivers with the drone. Here's the drone inside. Our ultra-wideband is already there installed with this. And of course, we need not only ultra-wideband, but also some software processing. For this, we have microcontrollers. And the final project demonstrators, they will integrate with these drones, and then we will show that it is feasible and very accurate for drones to autonomously land with ultra-wideband transceivers. The other project that we are working on with ultra-wideband and drones is upwards. It is mostly with BTU Cottbus, with the Technical University at Cottbus.
Ein bisschen auf die Zeit achten, bitte. Ein kleines bisschen auf die Zeit achten.
Wie viel Zeit habe ich noch?
2 Minuten, 3 Minuten Maximum, bitte.
Okay, mache ich 3 Minuten. So the next project is about coordination of drones, and similarly, we think that autonomous drones, the future of drones, and not only single drone, but the several drones, because with several drones, we can do missions much faster. The problem is when they are flying together autonomously, there are problems of collisions and some localization problems. But with ultra-wideband, with all of these drones, with ultra-wideband technology installed, they can easily detect where they are. And in case there are collisions problems, they can with ultra-wideband send commands, please fly higher or fly lower. In this case, we can just avoid collisions. So ultra-wideband would use for both communication and localization. And here is the same drones that we'll be using also. We're using for this project, and also we need also more software, because ultra-wideband is not enough. We need some intelligence, so software that just deal with ultra-wideband measurements. So with this, I'm going to conclude my talk. So this ultra-wideband, in our opinion, is very promising technology for drones because it can do both wireless communication and localization. And now we have 2 ongoing projects, thinking of other projects. And the next steps is we need new antennas. We need to look for formation of drones and many other aspects. And we think it's very, very attractive, and it will be probably future of drone communication localization. Thanks a lot for your attention. I hope I managed to get it in this time slot. And if there are any questions, I'll be happy to answer them. Thanks again.